Hi, this is Herb Shapiro with the Dr. Vax channel, and as we get started with this new year, I'm going to be repackaging and reviewing some of the materials that I covered in the first full year of this channel last year. We're going to start with a useful set of techniques for people that are brand new to 3D printing or people that have been printing for a while. We're going to talk about calibrating and maintaining your 3D printer. Because even if you get the very highest end printer, when it first comes out of the box, there's a chance it won't be properly calibrated. For consumer grade printers, I think it's probably at least a 50% chance that if you don't calibrate your printer when you first get it, you will not get optimal results. So stay tuned and let's learn something together. Okay, let's get started by going over the tools that I'm going to need to calibrate and maintain this printer. The first thing you'll need is a set of Allen wrenches because or hex wrenches, most 3D printers today use metric hex connectors, and we're going to want to be able to tighten various connectors. The second thing you'll need is some grease or oil. Now, there's a lot of discussion in the various user groups, Facebook chat groups about this. In general, people like to use a Teflon or PTFE based lubricant on 3D printers. And you want to generally avoid household oil. And the reason you want to avoid general household oil is there are a lot of plastic parts on here and potentially rubber parts. And household oils, depending on the oil, might cause those to deteriorate. So I generally use two different things. I use either silicone oil or I use a PTFE Super Lube grease, and I'll link these in the comments. Now, we'll talk about where to lubricate in just a moment. The next thing you're going to need is you're going to need a little ruler. I'm going to do this in metrics, so a metric ruler and a Sharpie. You're going to need some filament. I like using white because it's easier to see what I'm doing on white filament. And that's basically it. Now you'll notice that my hex keys or my hex wrenches look like screwdrivers. I find this style much easier to use. I don't have one big enough for every connector, every bolt on this Ender 5, so this is one that actually came with the printer. Okay, now let's go to the screen a minute and I'll give you an overview of what we're going to cover, and then we'll do all these steps. Step number one is check and make sure everything is tight. Now that might seem obvious, but these things are bouncing around a lot. Tighten everything up. It'll make your printer work better. Lubricate, step number two, metal on metal parts. Specifically in the case of the Ender line, in the Ender 5, you have this screw that's being used to raise and lower the Z-axis. That screw and these rods need to be lubricated. In the case of the Prusa, you also have drive screws and rods. Depends on the style of your printer, but metal on metal parts should be lubricated. Parts that have sealed bearings, inside the bearings, those are sealed, you wouldn't lubricate those. So basically, you're going to lubricate the drive screws and the various rods in your printer. You do not want to lubricate the belts. You do not want to lubricate the rubber on metal parts. That's not necessary. You're going to need to install a terminal application, a terminal monitor or a terminal application of some type, so that you can connect from a computer to your printer. That will allow you to send G-codes to your printer. Now, I've done a number of videos on these just a few days ago. I did one on a video using the G-code sender that you can load into Chrome. I'm going to use that today. Also, the Matter Control program from Matter Hackers, I highly recommend. It's free, it runs on all operating systems, it has a very nice terminal interface. Here in my shop, I often use Octoprint because I generally have an Octoprint, Octopi front end on most of my printers. But you're going to need to install one of those. You can check the channel for videos about those various options. Then we're going to calibrate the temperature of the hot end and the build plate. Now, PID calibration is an interesting thing because you would think you can just heat up the hot end till the thermistor, basically the thermostat that's on the hot end, gets to the right temperature, then turn off the electricity. When it cools off a little bit, heat it up again. But if you do that, you're going to actually end up overshooting and undershooting a number of times. So you need to use a very sophisticated algorithm called a PID algorithm. We'll talk about that in a moment. And then finally, we're going to want to make sure that when we tell this printer to extrude 100 millimeters of filament, it extrudes 100 millimeters of filament. And that's called the extruder step calibration. And we're going to do that also. Okay, so hold on because we're going to cover a lot of material here. But hopefully I'll have all of the material you need for maintaining and calibrating your printer really in one place for you. Okay, let's look at this slide. We're going to start with PID, or Proportional Integral Derivative Control Algorithm Calibration. As I mentioned, you don't want to just heat up your nozzle, stop, wait for it to cool off, heat it up again. You want to get it tuned so you can stay as close as possible. That means you need to heat it up at a certain rate. As you get closer, you need to slow down a certain rate. You need to let it overshoot just a certain rate. That's all part of PID calibration. Now, if we look at this screen, we're going to use a couple different G-code commands. If we send an M303 command, that will start the auto-tuning algorithm. And we'll watch that on the screen. We'll see it'll heat it up to a certain temperature, then it'll let it cool off, it'll heat up, it'll measure the amount of time. We can do that with an E0 if we're calibrating our hot end, or we can do that with an E-1 if we're calibrating our print bed. Then there are two separate commands, an M301 or an M304, to save those values into the EEPROM, to save it into your printer. But if you save those values, if you turn your printer off, those are going to go away. You have to permanently save those. And so to write those to the actual EEPROM, the permanent storage, you do an M500. All of this is explained in the reprap.org wiki. But let's go to our terminal control program, GSender, and look at this together. So I'm going to start by turning on my printer. I have it connected to my MacBook. And I'm going to switch to the G-code sender application. We'll start on the setting pages. We'll make sure it's connected to the right port. Once again, there's a video on this that I did just a couple of days ago. So just look in the channel and you'll see exactly how to set this up. This is specifically for an Ender this speed, but in general, this setting will work with most printers. Now I'm going to go to the control panel and I'm going to click on Connect. So I'm connected. To verify I'm connected, I like to do an M503. That will take and display the current settings. So I'm going to click on Send. And we'll see I'm connected and all of these settings are displayed, including, if we look down here, the current PID settings. So PID tuning will measure for us this P, I, and D values, these three values. We're going to have it auto-tune those and then enter them back in. So I'm going to go down here now, and I'm going to start with an M303, E0, our hot end, S220. Now, I like to tune it for a little bit hotter than my typical print temperature. I generally print Hatchbox PLA at about 206, but you also can use this to verify that your printer can get up to higher temperatures. So you could try tuning it for 240 or 250. If you have an all-metal hot end, I can go to 275 on this printer. So let's hit Send here. And now what you're going to see is a continual display of temperatures. And you can see that the temperature is slowly going up. It started at 26 degrees Celsius. It's now at 58 degrees Celsius and going up. And we're going to wait for that, or auto tune is going to wait for that to get just a little bit low, a little above the temperature we've selected. Then it's going to let it cool off, and it's going to do that, I believe, by default 5 times. So let's let this run now. Okay, we're making progress. We're up to 193 degrees. Okay, you'll see here that it actually allowed it to go a little bit above. Now it's letting it cool off a little bit below, and it's going to continue this cycle a number of times to get the right values. Okay, auto tune is finished, and it's telling us what values we should use. So we're going to enter an M301 because we're sending the values for our hot end, a P26.21, an I2.56, and a D67.04. We'll see we received an OK here. Now that's stored it in the real-time memory on our printer. We want to store that now in the EEPROM so it's there when we come back. So 26, 2.5, and 67, M500. We received an OK. And now if we do an M503 to see what's stored, and we find our PID settings here, we'll see that our new values, 26, 2.5, 67, these were the values here, 26, 2.5, 67, are now the values that are stored in our EEPROM. We can do the exact same thing by issuing an M303 E-1 S, let's say 60, in order to tune our print bed. And then we use an M304 command to store those away. So we've now learned about PID tuning. And it is important to get this right. And the reason is because if you go onto the web and you find recommended temperatures for various PIDs, various filaments, if your printer is not calibrated properly, those temperatures won't work on your printer. So calibrating the temperatures on your printer is a great way to start towards printing better prints. Now what's the next thing we need to do? We need to calibrate how much filament is extruded. And now let's talk about extruder calibration. Here are the steps we're going to take. We're going to mark off 120 millimeters of filament. I'll show you why it's 120 in a minute. Then we're going to extrude 100 millimeters of filament, and we're going to measure how much actually was extruded. Now, we're not measuring what comes out of the hot end. We're measuring how much is fed through the extruder. So you're going to need a ruler for this. I have a metric ruler. You'll notice I took my reel of filament off because that gives me easier access to measure straight down from the base of my extruder. And I want this to be right on a spot that I can measure to every time. It doesn't matter what spot, because you're measuring the amount of filament extruded. So as long as you measure from the same reference point, it will be good. Let's see here. And I marked off 120 millimeters. Now, to be very honest, this is going to be relatively accurate. Let's say plus or minus a millimeter. So once again, you could do this many times. You could use a finer tool than the Sharpie to mark it. I think this will be good enough. So now let's go back to our console. The first command we're going to issue is a command to put the printer into relative mode, because that's the standard mode that is used by most slicers for extruding filament. And since we're in relative mode, we have to zero out the starting position. So the G92 will zero out the starting position. You'll see here this is showing you where our X, our Y, and our Z, our X, our Y, and our Z is currently located. And it will show us that the extruder right here is currently at 0. Now, before we can extrude filament, we have to heat up the hot end. We could do that from the console, or we can use a command to do that. So I'm going to do an M104 S206. I'm using 206 degrees because that's the temperature I normally use for Hatchbox PLA. So since I have Hatchbox PLA in here, I want to make sure the extruder is going to work at this temperature properly. Now I can watch the front console until it gets to 206, or I can issue an M109 command, S206, and that's going to tell the printer to wait until the temperature comes up to the proper temperature, 206 degrees Celsius, before continuing, and it will display that on the screen. Now you'll see these busy commands are because the flow control between this G sender and the printer is not perfect. It's fine for our purposes. I'm not sure I would use this Chrome-based G sender to send a actual print job, but for this purposes, it's perfect. We can see the current temperature right here. Let's see if I can get that line highlighted as it moves away. So it's coming up to temperature relatively quickly. And it should come right up to the right temperature because we just tuned our hot end. So you want to do PID tuning first, then extruder calibration of your printer. Okay, we should be pretty close. And you'll see we received a little OK here in the corner. That OK says that the printer thinks we are ready to go. Now, we've marked off 120 millimeters. We're going to tell the printer to extrude 100, so it should get to about 20 millimeters of that dot. If it gets to exactly 20 of that dot, then our extruder is already calibrated perfectly. So to do this, we're going to say do a controlled extrusion, a G1, E100, extrude 100 millimeters, F100, extrude at 100 millimeters per minute. The F command is per minute. It's a little bit unusual. This is really relatively slow. It'll be a good test at slow speed. We could do it at a much higher speed. We could compare the results. This is a good place to get started. So we're going to go ahead and get that going. You'll see the knob here is turning and the filament is moving. How long is this going to take? Well, we're extruding 100 millimeters at F100. That means 100 millimeters per minute. So this test is going to take 1 minute. Now, don't worry about the filament over here. You're not going to be measuring that at all. That's the amount extruded is not going to be 100 millimeters. It's going to be a lot more than that because 100 millimeters is how much you're feeding in. Your slicer calibrates based on the diameter of the filament, the diameter of the nozzle, the feed rate, how much is actually getting extruded. That's a complex mathematical process. And we can see here it just finished because we got an OK on the screen. So now let's measure this. And if it's exactly 20 millimeters, which this one is exactly 20, then our extruder is currently calibrated perfectly. If it's less than 20, then we fed in more filament. We are over extruding. If it's more than 20 millimeters left, then we're under extruding because we told it to extrude 100 millimeters. We marked 120. So that delta should be 20 millimeters. So we need to calculate the steps, the number of steps, the number of turns on our stepper motor to take to calibrate 100 millimeters. So we need to take the old steps, in our case, that was set to 95. I'll show you how we see that. Times 100 divided by the actual amount of filament extruded. Now, ours is actually 100. So 100 divided by 100 is 1. So we're not going to be changing it. But let's say we marked off 120. The measured amount was 29. So the actual extruded was 91. Then the new steps is equal to 95 times 100 divided by 91, or 104.5. So we'd want to enter that into our printer. So let me show you how we do that. Let's go to the screen here. I'm going to clear the log. I'm going to do an M503 to see the current values. And we're going to look for a 92, right here. This line right here. And let's actually take and copy that line. I'm going to paste that line in here. And now I'm going to replace the E with the new step value. Well, in our case, it was perfect, so we don't have to change it. So we can see here that when I click the enter, I received a OK over here. Now, once again, that's in the temporary memory, an M500. And let's click on send. And we can see we stored that into our permanent EEPROM. So let's wrap this up by reviewing what we did. So to maintain and calibrate your printer, first of all, check that everything is tight. Belts should be tight. Now, on the Ender line of printers, there are not adjustable belts. Some of the other printers have better adjustments. There's a little bit of play in here. So you can loosen these bolts and pull this out. Basically, as long as your mechanisms move smoothly, you don't have to worry about over-tightening those belts. There have been a number of videos done. The Chuck over at Filament Friday did a wonderful video on this recently, and he found you really can't over-tighten the belts. You don't want to break them, but you really can't over-tighten them. Now, on Ender printers, you also have these rubber wheels. Now, on these rubber wheels on the inside, you have what's called an eccentric bolt. That means it's a bolt that when you turn it, it's not centered. So by turning it, you can pull a wheel in or out. There's one on here. When these are properly configured, properly calibrated, when you move this slowly, you should see all 4 of the wheels moving. Another calibration you should do on this printer. Lubricate metal-to-metal parts. Don't use regular home lubricant. Use either a Teflon-based or a silicone-based lubricant. Run a PID calibration, an extruder calibration, and you should be printing beautiful prints. Well, folks, if you found this useful, give me a thumbs up. Share this with everyone. You're free to share these videos, these URLs with anyone you'd like. Leave me comments, suggestions, criticisms. I'm interested in everything you're thinking about these videos because that's how we'll continue to learn together.